C alpha divided by 2, that corresponds to an 88% level of confidence, and I like hit the help me solve this button that helped me try to solve it, but I didn't know how to do it.
So we had a similar example last time, so let's do this. We always graph. That's the easiest thing to do. So first of all, this must be 88%. From 100% minus 88%, we have 12. Is that correct?
Yes.
Okay, which means that this tail has 6%, and this tail has 6%. But this has to be 0.06 because we cannot enter it in the calculator like that. Next step, I'm going to share my screen. My calculator is ready. Okay, this is from Newton's method in my Calc 1 class. So let me clear all this. So second and distributions, and we go to inv norm and enter. I like to put the area to the left, although calculators now, I guess, are way more sophisticated. 6% in the left. So I want this. I want this. So the z on the left is negative 1.5547. And of course, the z on the right, this point here, is negative 1.55.7, and this point here is positive 1.5547. And remember what we said, for some reason, the way they created the table for z, when they talk about this, they want the positive. Okay? So they want 1 point, I don't know how many decimal digits, I have to go back.
It says 2 decimal places.
Okay, so in this case, 1.55.
Yep, and it says it's correct.
So again, it is a little bit confusing because you saw that StatCrunch uses the opposite. So I know it's a little bit confusing, but just remember when you plug in, do not plug in the left, meaning the negative value, but the positive value.
Okay, thank you.
Thank you. Other questions, anyone? Anyone, other questions? Okay, so I would like to go back and then if we don't have other questions, I'd like to go back to the last, I don't know, I don't remember exactly, but we'll find them together. The last 4 or 5 questions from 9.2. Anyone, any questions? I can stop anytime if you find something or if you want to ask something. Anyone remembers which problem we were on? Okay, if we don't remember, that's okay. Let's go back from the last one backwards, and then we'll stop where we remember doing. Okay. Good. So anyone would like to start this? Help us start this problem? Anyone? Okay, thank you, Emma.
You're welcome. A doctor wants to estimate the mean HDL cholesterol of all 20 to 29-year-old females. How many subjects are needed to estimate the mean HDL cholesterol? Within 4 points, with 99% confidence, assuming the sample equals to the S equals 12.9 based on the earlier studies. Suppose,
okay, hold on one second. Once we read this sentence, we have to understand that E, the margin of error, is 4 points. The confidence interval is 99%, and the standard deviation from a previous sample is 12.9. This is what we have to write on paper immediately. Excellent. Okay.
Suppose the doctor would be content with 90% confidence. How does the decrease in confidence affect the sample size required?
Okay. So then, obviously, we want to calculate everything again with a 90% confidence interval. So first we will determine the sample size. This is what I wanted and I didn't get the chance to get to last time. So I'm going to call it N1 and this is N2. So the sample size with margin of error 4, of course, everything is the same except the confidence interval or confidence level. Okay, so now let's remember the formula for this. So we have X bar minus E and X bar plus E This is the confidence interval for mean, the population mean, mu. Okay, so this, which is the margin of error, has a formula. Okay, for the sample size, because normally I would have written t, right, alpha over 2 times s over the square root of n. But I cannot determine t. Remember, t depends on degrees of freedom, n minus 1. So I can't determine it if I don't have the sample size. So it's okay to use z. What's z? Z for this. I'll come back and explain again that. So I'm going to write it alpha over 2 and s over the square root of n. Now, how do I solve this equation? I have this, I have this, I have this. How do I solve this equation for n? Yes, you can just write the formula, remember the formula, or you have it ready. Fine. But I would like to do a little bit of arithmetic here. So, or algebra. I'm going to square both sides. So e squared equals z squared times s squared divided by n. Why do I square? Because I want to remove the square root from top of n. So this squared, this squared, this squared, and this squared is just n. Multiply both sides by n. N e squared equals z squared alpha over 2 times s squared. To get n, I divide by this. So n equals a fraction, and the denominator e squared, and the top of these two. Z alpha over 2 and s squared, both of them, of course. So this is how I'm going to calculate. First, I have to determine with inv norm, I have to determine what z alpha over 2 is for 99, and then what z alpha over 2 is for 90. So in order to determine n1, stop me if you have questions, please. For n1, and then for n2. So for n1, I have to determine, so this is for 99%, and this will be for 90%. So I draw my graph. I know that the middle, 99%. I know that this piece is 0.1. I'm sorry, it's 1 divided by 2. So 0.05, right? So 100, let me write it here, minus 99 is 1. So this is 1%. It's 0.01. So when I divide 0.01 by 2, I get 0.005. And this is 0.005. I'm using this. They have to be, these are called tails. We're going to come back to it today, again, to those tails. So I have to use inv norm, the area to the left, 0.005, of course, 0 and 1. And I get this and this, the negative and the positive. The same thing on this side. It's just this time I have 90%. So again, 100 minus 90% is 10%, which will be 0.1. When I divide 0.1, this piece is 0.05, and this piece is 0.05 to make up the 1%, 100%, or 1. Okay, so then the same thing, I will be using the inv norm, but this time the area to the left is 0.05, and then of course 0 and 1, mean and standard deviation, and I will get these two. Then after I determine these numbers, then I will determine n1 as being this number squared multiplied by what was s 12.9 squared divided by 4 squared. Same thing here. And 2 will be whatever we get from here. This number will go here. And times 12.9 squared and divided by 4 squared. So now with inv norm.
So I got the I got the numbers. So for the 99%, it's going to be negative 2.57, or yeah, 58, I guess, if you want to round.
Good.
And then for 90, it's going to be negative 1.64.
Yeah, you're right. You're right. You're right. You're right. This is for 95. You're right. 1.64 it is.
Yes.
6458 actually. Yes, I was thinking of 95. Good. So then here, of course, I'm not going to use the negative. Even if I want to use the negative, it's going to be squared, so it doesn't make any difference. So 2.575 squared, and here 1.645 squared. So now let's calculate. Where is my calculator? Oh, I have the, let me share my screen. Okay, so we want, it is 1.645, correct? I'm not,
Yeah.
Yes, okay, just to make sure. Good, so then all I need to do now is put left parenthesis, 2.565, 2.575, I meant to say, times 12.9, everything divided by 4. And I square the whole thing once, because I'm lazy. I don't want to put square here, square here, square here. I calculate, everything is squared, so I'm going to do this. And then for the other one, I will replace 2.565 by 1.645. 1.645. Do you expect this number to be smaller or bigger? Don't say anything. If I decrease the numerator from 2.5 to 1.6, this number has to be, the answer has to be bigger or smaller?
Smaller.
Yes, because I decreased the numerator. Of course. So now remember, regardless of what is after the decimal point, just for the sample size, this is not what we do normally. So regardless of what follows after in the 10th unit, we have to increase this to the next level. So the first one is clearly 69, but the second one is not clearly 29, but it has to be 29. Otherwise, the margin of error, 4, is not guaranteed to be 4. So that's the reason why we always, no matter what this number is, we have to raise by 1. Where am I? I'm here. So for 99, I got 69. And for the other one, 29. Okay, so now what do we conclude? How does the decrease in confidence from, I no longer, so he doesn't want to be 99% confident. He's happy with 90% confidence. And from 99 to 90, the decrease in the confidence level, this is what it did in the number of subjects needed for the study. So what will you pick?
So I would pick C. Decreasing the confidence level decreases the sample size needed.
That's it. Because we decrease the numerator. Very good. Okay, so let's go back. Let's see if we need anything else. Now you tell me, this is all I wanted to do so I can show you an example with finding the sample size. If you would like to work on any other problem, let me know. Don't let the guard down now. 3 weeks left, so we need these 2 chapters, 10 and 11. Other questions? Anyone needs anything else from section 9.2?
I don't have any questions.
Okay, anyone else? Thank you so much. Anyone else?
No, ma'am.
Okay, in that case, let's start chapter 10. In chapter 10, we have 3 sections. So chapter 10. So please pay attention to chapter 10 and ask questions because I'm not saying that it's difficult. I'll repeat things. We'll work on all problems that we need to, but it's a little bit more involving and a little bit more interpretation type of chapter. Okay, so this is called hypothesis testing. Hypothesis testing. Okay, so how do we estimate? We only looked at, there are many parameters for the population, but we only looked at proportion, population proportion, and population mean. And then we are going to stick with these two. We can estimate raw, which is correlation coefficient. We can estimate sigma, which is the standard deviation, etc., etc. But we're not looking in this class at anything else but population proportion and population mean. And let me refresh your memory. We looked at 3 different things, actually 2, and we're going to look at the last one now. First, we looked at the point estimate. I have to have a point estimate. So we said that p hat and correspondingly x bar were point estimates coming from the sample, p hat from the sample, x bar from the sample. They were good estimates of population proportion and population mean. Second one, confidence interval. We looked at confidence intervals to estimate the population proportion and population mean. What did we say? I am 95 as an example, 95% confident that this particular interval contains the population proportion or the population mean. Okay, so this was the confidence level. Okay, and I'm going to come back to that. We're going to talk, I'm going to compare again the 95% with what we're going to do here. Okay, and the last one is hypothesis testing. So to estimate a population parameter, either proportion or mean, we looked already at point estimate and confidence intervals, and now we're going to talk about hypothesis testing. What is the target? To estimate or basically test a claim. So this is for testing a claim or a statement of course about. Good. So our next step. Steps here in hypothesis testing. There are 3 steps. We formulate or state the claim. And you can say you state the claim before you determine the sample mean population. Yes. We state the claim and then collect the sample. From the sample, we will determine a test statistic. Once I have the sample, I will determine a test statistic. It will either be Z statistic, ST, for population proportion, or it will be T statistic, and you know where these come from, standard normal, and T, student T distribution, of course for mu. So I state the claim, I collect the sample, I determine a test statistic. It could be this or it could be this, depending on what the hypothesis is all about. It could be about a proportion or it could be about a mean. I don't know. But if it is about proportion, I will determine the test statistic ZST. This is listed as Z0. Fine. If we don't like this notation, you can call it Z0. If you don't like ST statistic, you can call it T0 as they use it. but this is the best notation because it tells you what is the zero. Maybe, but I think this is a better notation, the z statistic coming from the sample and the t statistic coming from the sample. And finally, I draw a conclusion. In other words, what will be the conclusion? Either my claim was supported by the information coming from the sample, or it was not. Because I didn't know, right? I stated the claim, I collected the sample. Based on what I get from the sample, I draw the conclusion. And what the conclusion could be, and I'm going to write this down, either my claim has meaning or has merit, or it does not. So allow me to